You ever wonder how an app on your phone or some website you use every single day can handle millions of people using it all at once without just completely falling over? Yeah, it's not magic. It's actually a journey of really clever engineering. So let's dive in and map out that exact journey, from just a single server all the way up to a global scale system. For any new application, that first step is always the simplest setup you can possibly imagine. We're going to start right there at the very beginning. One user, one server. That's it. And here it is, the humble beginning. At the very start, everything, the web app, the database, you name it, it all lives inside one single server. This is the classic garage setup. It's super straightforward, it's cheap, and honestly, for your first few users, it works perfectly. So how does that user actually connect to our server? Well, it's kind of like a four-step dance that happens every time. First, you type in the domain name. Then, a system called DNS, which is basically the internet's giant phone book, looks up the server's unique IP address. Your browser then sends its request to that address, and finally, boom, our server sends back the web page. Simple, clean, and for now, totally effective. Okay, but this is where things start to get really interesting. That one little server that was doing just fine, well, now it's starting to sweat. The application and the database are fighting over the same resources, the same brain power, the same memory, and everything just starts to grind to a halt. This is our very first major growing pain. And this brings us to the first big rule of scaling. You have to divide and conquer. So we split our all-in-one box into two specialized teams. We have a web tier that just deals with users and a data tier that just manages the database. And the big win here, it's that we can now upgrade each one on its own whenever we need to. Now that we have a dedicated home for our data, we have a big decision to make. Do we go with a classic SQL database? Think of it like a super organized spreadsheet, structured, reliable, great for most things. Or do we go with no SQL? This one's built for pure speed and handling massive amounts of unstructured data, like, say, a social media feed. It really is all about picking the right tool for the job. So, how do we actually make these tiers more powerful? Well, one option is to scale up. You just buy a bigger, faster, more expensive server. But there's a hard limit to that. You can't just buy a server with infinite RAM. The real secret to massive scale is to scale out. You just add more servers to your team. It's a bit more complex, but it's absolutely essential for what's coming next. Right, so we're thinking about scaling out, but we've still got a huge problem staring us in the face. We may have separated the database, but we still only have one web server. If that one server fails, our entire application goes dark. That's what we call a single point of failure, and we have to get rid of it. The solution is a beautiful little device called a load balancer. The best way to think about it is like a traffic cop for your website. It stands out in front of all your web servers and smartly directs all the incoming traffic, making sure no single server gets totally buried in requests. And just like that, bam, our web tier is now resilient. We've scaled out by adding more servers, and the load balancer splits the traffic between them. Now, if one of those servers goes down, the load balancer just stops sending traffic its way. The user has no idea anything even happened. The site just stays up. Okay, great. Our web tier is solid, but we haven't really solved the problem, have we? We've just moved it. Now we have a new single point of failure, the database. If that one database server goes down, everything grinds to a halt again. So how do we make the database just as tough? We do it with something called replication. We basically create backup copies of our database. The original is called the master, and all the copies are called slaves. This is a classic, powerful pattern for both reliability and performance. Now here's the really clever part. The work gets split up. All the new data, the writes, goes to the master database. The master then automatically copies those changes over to all the slaves. And the slaves, their only job is to handle requests to read data. Since most apps have way more reads than writes, this strategy is a huge performance booster. All right, so our system is now highly available. It's tough. It can survive failures. But now a new complaint starts rolling in from users. It's slow. Every single page load needs to talk to the database, and even with all those slaves, that can take time. So the next phase of our journey is all about one thing, the need for speed. The number one weapon in the fight for speed is the cache. A cache is just a super fast temporary storage that holds on to data that gets used all the time, like, say, your user profile. The goal is to avoid that slow trip to the database every single time we need it. So here's how it works in practice. When a request comes in, the web server checks the cache first. If the data is there, we call that a cache hit, it gets sent back to the user instantly. If it's not there, a cache miss, okay, no problem. The server goes and gets it from the database, but it stores a copy in the cache for the next time and then sends it to the user.
Caching is amazing for our data, but what about all the heavy stuff? Images, videos, big code files. For that, we use something called a content delivery network, or CDN. This is basically a whole network of servers spread all across the globe that store copies of our files.
And the benefit here is enormous. It means a user in, say, London, who wants to see an image gets it from a server right there in Europe, not from our main servers back in the US. This slashes load times and takes a huge amount of pressure off our main system. Our app isn't just reliable anymore, it's fast. Now, to truly scale across the globe, we have to make one more critical change to our web tier. We need to go stateless. See, a stateful server remembers things about you, which means you have to keep getting sent back to that same server every time. That's a nightmare for scaling. In a stateless world, all that information is stored somewhere central. This means any web server can handle any user's request, and that is the key that unlocks true global scale. But what about really slow jobs, like processing a video you just uploaded? You don't want the user to just sit there waiting. For that, we use a message queue. Our web server, the producer, just adds a job to the queue, like, hey, process this video, and immediately tells the user, got it. Then, totally separate worker servers, the consumers, can pick up that job and process it in the background. It decouples our whole system and makes everything way more resilient. We've done all this amazing work. We've optimized everything around the database. But eventually, with millions of users writing data all the time, that single master database becomes the final boss. It's the ultimate bottleneck. It just can't handle any more traffic. So how do you scale the one thing that seems unscalable? The answer is sharding. Instead of trying to make one database bigger and bigger, we actually split it apart into a bunch of smaller, faster databases called shards. So for example, we could put all the users with last names from A to M on one shard and all the users from N to Z on another. We are literally scaling the data tier itself horizontally. And that really brings us to the finish line. This entire incredible journey from one user to millions, it really just boils down to these core ideas. Keeping your web tier stateless so any server can do the job, building in redundancy everywhere so nothing can take you down, caching absolutely everything you can and using CDNs for speed, decoupling your systems, and finally scaling the database itself with sharding. Every step is a piece of a much larger and really clever puzzle. But here's the thing about scaling. You're never truly done. Every single solution we've talked about, from load balancers to caching to sharding, it solves one problem, but it always introduces new kinds of complexity. It's just a constant cycle of finding the next bottleneck and then figuring out how to smash it. So looking at this whole system we've built, what do you think would be the next thing to break?